Hey guys, this is the full review for exam 4. Welcome. So for question 1, they just want us to pick the graph that represents the function y equals 2 to the power of x. So here we have 4 different options of different lines going through different points on the xy axis, right, is how I would describe this. For example, let's label them A, B, C, and D. For this, for graph D, I see that it's going through the point 1, 1, right? So if I were to make an XY table, it would be X is 1, Y is 1. So when X is 1, 2 to the power of 1, is Y equal to 1, right? If it is, then it'll be either D or C or B. Yeah, those all look like they go through the point 1, 1, right? So that's one way to solve it is find some find places where the graph is different for each of the options. Here, it looks like it goes through the point. Sorry, that's 0, 1. What am I? Sorry, guys. Hopefully you caught that before I did. Don't believe everything I tell you. Here is the point 1, 3. Makes a little more sense. Here it goes through the point, looks like 2, 4, right? 2 on the x-axis, 4 on the y-axis. This does not go through anything on 0, right? When x is 1, it's kind of hard to tell. When x is 2, it's still hard to tell, hard to tell. It might be 4, 1, it might not be, so I don't know. There aren't any super obvious points for A. B, we have the point 0, 1. That might be negative 2, 4, right? All right. So y equals 2 to the power of x. I'm going to take the equation and I'm just going to put in 0 for my x and find out what y is. This is for this equation, okay? This is not for any of the graphs that we're looking at necessarily. Instead of x, I'm going to put in a 0. 2 to the power of 0 is just the number 1. So when x is 0, y is 1. Okay? So that means it does contain the point 0, 1. This 0, 1 is that point, so it cannot be A. I've eliminated A. It's either B, C, or D. Just go to the next number. What have we found? We found the point negative 2, 4. We found the point 2, 4. And we found the point 1, 3. Okay? So I'll just put in when x equals 1, what should y equals? Y equals 2 to the power of 1. So y equals 2 when x is 1. That's the point 1, 2. 1, 2. It's not that one. 1, 2. It's not that one. 1, 2. It is this one, right? So I suspect it's this one. I can try to put in another point. 2, 4 is clearly, it crosses through 2, 4. So if I put in 2 for x, do I get 4 for y? Again, we're using that equation. Y equals 2 to the power of 2, because that's my x, which is 4. So when x is 2, y is 4. So I'm going to pick that graph. You are also always welcome to graph it in Desmos. You would just put in y equals 2 to the power of x, 0, 1. Find some other point, 0, 1, 1, 2, 2, 4, and those will all be, they'll now start showing up on your graph. Okay, and so you can say, which one does that look like? So that looks like C to me. So that's how I do number 1. Question 2 asks us the graph that represents the function y equals 1/2 to the power of x. Okay. Again, if I was to make an XY table and substitute in various values of X into that equation, what would the Y give me? If X was, I like to start with 0 because anything to the x1 of 0 is just 1, right? Y equals, so if X equals 1, Y equals 1/2 to the power of, oh, sorry, if X equals 0, Y equals 1/2 to the power of 0. Kind of hard to read. Y equals 1, right? Anything to the power of 0 is 1. So when X is 0, Y is 1. X0, Y is 1. That is there. X is 0, Y is 1. X is 0, Y is 1. This one, no. So we can eliminate that fourth option. Now, do I see any other obvious points? I do not, but I do see that when X is 1, it's either going to be, oh yeah, that is an obvious point, sorry. When X is 1, is Y going to be 2? Or is Y going to be closer to 1/2 or 1/3, right? So when X is 1, we have Y equals 1/2 to the power of 1. So Y should equal anything to the power of 1 is just itself. So when X is 1, Y is 1/2, right? So that's not going to be this one because here when X is 1, Y is 2. So either this first graph or this third graph is 1/1/2, right? It looks more like it's this one, we're not sure. So if I'm trying to decide between these two, instead of just going to 2 and saying, okay, that's just another fraction, I can tell, right? I'm going to see if there are any points like if it was -1, if X was -1, is Y going to be 2? Or when X is -1, is Y going to be 3, right? Is it going to be 3 or is it going to be 2? Might use a different color just to. -1. Okay. Is -1 going to equal 3 or 2? That means we have when X is -1, Y equals 1/2 to the power of -1. I'm going to put that into my calculator. 1/2, or you could say 0.5 to the power of -1. That gives me a positive 2. Which graph is that? That's this graph. So that's how I would decide. Again, you're welcome to use Desmos, okay? But I would just be plugging points, making up X values, finding the Y, and then seeing which of the graphs that matches. Question 3, select the domain, select the graph of the transformation of f of x equals 4 to the power of x and give the horizontal asymptote, the domain, and the range. So it's not just f of x equals 4 to the power of x, it's f of x equals 4 to the power of x plus 3, right? Again, you're welcome to just plug in points to get the graph. What points do I see? Here we've got 0, -2, maybe 1, 1. Here we've got 0, 4 for sure. Maybe 1, 7. Here I can't see anything super obviously except -3, 1. And here I can see +3, 1. Okay, so it looks like if I put in 0 for x and I get either 4 or -2, I'll know. If I put in -3 for x and get 1 for y, I'll know it's this. If I put in 3 for x and get 1 for y, I'll know it's this. Okay, that's how I would do it. So let's start. All right, had to add some color. I thought that since we were graphing, I could get away with no colors, but it's confusing. All right, so if we wanted to check, let's check 0, right? Is 0 going to be equal to -2, or is 0 going to be equal to 4, or neither of those, right? Is it going to be equal to something close to 0, or is it going to be equal to some really huge number? Okay, so when x is equal to 0, what is y? Or what is f of x? F of x, because y is f of x. F of x equals 4 to the power of 0 plus 3. Let's simplify that. 4 to the power of 0 is just 1 plus 3 is 4. Okay, so when x is 0, y, or f of x, is equal to 4. Which graph does that match? That matches only this one. Okay, so that's how I'm going to pick my answer. I went and got color and it doesn't work. It matches this one. All right. You can check another point. It looks like it was 1, 7, right? So when x is 1, what is y going to be? Well, when x is 1, f of x is 4 to the power of 1 instead of x plus 3. 4 to the power of 1 is just 4 plus 3 is 7, right? So when x is 1, y is 7. That does match this information. Okay? The horizontal asymptote means what is it approaching and never touching? And you can just see on the graph. So you don't have to do anything with the equation if you don't want to. The horizontal asymptote is at y equals +3 because that's what it's approaching and never touching forever, right? The domain. Remember that the domain is all x values. So only along the x-axis, I'm going to move it up because we only need to be looking at this graph now. So only along the x-axis, what's happening? It's going forever in this direction, right? It's going forever in this direction. That's the negative infinity direction. So I'm going to say that the domain using interval notation is from negative infinity to positive infinity. The range is all y values. Meaning up and down. What's it doing? Start with the negative direction, right? Because that's the first number we're going to put in. How far down does it go? It goes down to, it approaches 3, it never touches 3. Okay, +3. From 3, it goes up forever. So I'm going to call that infinity because it's going forever in a positive direction. It does not go forever in a negative infinity direction. It stops at 3 or before 3, right? It approaches 3 forever. Question 4 asks us to graph the transformation of f of x equals 3 of x and then give the horizontal asymptote, the domain, and the range. So kind of similar, except it doesn't give us different options, right? So we can go just straight to your xy table. Remember that y is f of x. I'm going to start with 0 because it's the easiest one to plug into anything, right? So when x is 0, what is y? When x is 0, f of x equals 3 to the power of -0. -0 is the same as 0, so it's just saying 3 to the power of 0, which is 1. Anything to the power of 0 is 1. So we have the point 0, 1. Okay. Now we can go to maybe -1 and +1, right? When x is -1, f of x equals 3 to the power of -1, right? Because it was a negative x, but the x is -1, so we have a double negative, which is 3 to the power of 1, which is just 3. So that's the point, -1, 3. Okay. Now, I know that this is going to get really small, right? Because 3 to the power of a negative exponent is going to give me a fraction. So you can find that. It would be a -1/3. Or you can go to -2 and it'll be all the way up to 9. So they're both, that one's off the graph and that one's kind of hard to determine what it is. So I would just go off of these 2 points, make my graph. Okay. Horizontal asymptote. All right, let's think about the horizontal asymptote. If we were to graph this, right? We're going like, it's going to go through 9 up here, right? 7, 8, 9. I'll make it look a little bit realistic. And then it's just going to go like this. And what are we doing? We are saying that if x is 1, y is 3, sorry, 3 to the power of -1, which is 1/3. If x is 2, 3 to the power of -2, which is 1/9, right? And so our fractions are just getting wanted to make sure it was 27. I got nervous. Our fractions are just getting tinier and tinier, but it's never going to be a negative number and it's never going to be 0. So it's just going to get really, really small. If I were to show you in Desmos, this is what it would look like, right? So we have the graph 3 to the power of -x. We have the point -1, 3, 1, 0, 0, 1, 1, 1/3, 2, 1/9, right? And then I typed in 100. And if you go all the way out to 100, it's almost at 0, but it's really not if you look at the table, okay? So it's clearly approaching 0. And so we're going to call the horizontal asymptote 0. In an equation, the way you find the horizontal asymptote is f of x equals a times b to the power of x plus c, and your horizontal asymptote is at y equals c. Good? Here, our c is just 0, right? Our b would be 3. We don't have an a, we don't have a c. C is 0, so our horizontal asymptote is at y equals 0, because you see that the graph is just approaching and never touching y equals 0. That fraction is just getting smaller. The bigger the x is, the smaller the y becomes without ever touching 0, okay? Domain and range, we're just going to do the exact same way that we did it for question 3. The domain are all of the x values. So in this direction, our graph is approaching infinity, right? It's going forever in that direction. Here it's going up, but it's also going to the left. So it is approaching negative infinity. So we're going to say that the domain is from -infinity to infinity. And our range means our y values. So going up and down. Down, what is it approaching? It's approaching 0. It does not go below 0. It doesn't touch 0. So we're going to start at 0. And then what does it go? It goes up forever, so that would be positive infinity, okay? Start with a graph of f of x equals 8 to the power of x and write a function that results from the given transformation if you reflect it about the x-axis. So here we're going back to the transformation rules for functions, okay? I'll show you my little table of the transformation rules for functions. And they are that if we add d to f of x, we go up. If we subtract d outside of x, we go down. If we add within x, right? Within the parentheses, if we add to x, that means we move left along. So in the negative direction on the x-axis. If we subtract, that means we're moving right or positive on the x-axis. Now, this question said, let's read it again. Reflecting about the x-axis or over the x-axis means we turn the whole thing negative. All right. So we started with f of x equals 8x, and we need to change it to reflect over the y-axis. We need to make it negative f of x. I want you to see the difference between reflection over the x-axis, reflect x-axis. Sorry, I know I'm not showing you this. Reflect y-axis. Notice the difference. To reflect over the x-axis, you turn the whole thing negative. To reflect over the y-axis, you make the x negative. Those are the differences. I'll stop sharing my screen. I'll go back to the page. So we have f of x is 8 to the power of x. To reflect it on the x-axis, we make the whole thing negative. So that becomes, don't use the same color as question 4. That becomes negative 8x. We made the whole thing negative, right? If you want to reflect it over the y-axis, which is not what the question 5 asks, but the difference between them is you keep the 8 positive and you make the x negative, right? We only made the x negative to reflect over the y. We made the whole thing negative to reflect over the x. So g of x is equal to negative 8x. Good. Let's check it in Desmos. You are always welcome to do this. Get rid of those. We've got 8 to the power of x. Get back in the middle here. We want to reflect it across the x-axis, which is the horizontal line, right? So we said it's negative 8 to the power of x. That is reflected across the horizontal line. If we had just kept it 8 and made it negative x, that would have reflected across the y-axis, the up and down line. So we wanted to do that, and so we just made the whole thing negative. Good. Stop sharing. Question 6. Oh no. Which of these graphs are one-to-one? All right, I wanted to get both. Oh no. Sorry, I print on both sides of the page. All right, we've got A, we've got B, and we've got C. Which of these graphs are one-to-one? And you can select more than one. All right. What is the rule for a one-to-one function when you only know the graph, you don't know the equation? Is a horizontal line, a graph is one-to-one, or an equation is one-to-one when a horizontal line crosses the graph once. Any horizontal line you put on there, it will cross the graph only one time or never. Good. So you want to find your straight edge, horizontal, left to right, right? Draw a line. If it crosses in two places, not one-to-one. This one's looking okay, right? That crosses once. That crosses once. It gets a little bit harder to draw the line down here. It looks like you can just draw a line across, right? But if we were to go into Desmos and zoom in, zoom in, zoom in, you would see that that line is still going down. It's going down forever. And then we have option C. Very straightforward, right? No matter where we draw the line, horizontally or vertically, or even diagonally, a straight line will never cross more than once, right? So I'm going to say that C is 1-to-1. B was not 1-to-1 because B had this shape, and we were able to cross it like this. And then A was in fact 1-to-1. Because if I graph A, we'll just say A was 8x, right? We know it's not negative 8x. It might be 8x. You zoom in, that looks like a straight horizontal line, but as you zoom in, I wonder if it'll be able to. It's so minute. That number is technically different from that number. That's still decreasing, right? The X value, sorry, the Y value, it is going down. So there's 2662, 2662, 2663. So it is still going down very, very, very subtly. All right, question 7. For the following one-to-one function, find the equation of the inverse. How do we find the inverse of a one-to-one function? All right, so the equation of the inverse means we are going to switch the x and the y, basically. Okay, so you can just flip the x and the y. Just like if you had a table of values and you're trying to find the inverse, you would switch the x and the y. So here, f of x equals 4x plus 6, or y equals 4x plus 6. The inverse is going to be x equals 4y plus 6. Does that make sense? So we switched the x and the y. What we get, and now we solve for x. No, we've already solved for x, we solve for y. So move everything over here. Here, y is being multiplied by 4, and then 6 is being added to it. You can subtract 6 from both sides. Now we have x minus 6 equals 4y. We're trying to get y alone, so we divide by 4, and we get y equals x minus 6 divided by 4. Good? You can also just think, okay, it's the inverse, it's the opposite. So the opposite of whatever's happening to x, the inverse, the opposite is happening to x. X is being multiplied by 4, so here I'm going to say the inverse is it's going to be divided by 4. The opposite of multiplying is dividing. 6 is being added. I'm going to subtract 6. You just got to make sure you do it in the right order. This will always work, okay? So if you have 4x plus 6, the inverse of that will be x minus 6 divided by 4. What I did was I switched the y and the x, and then I solved for y again to get y equals x minus 6 over 4. Graph the inverse of the function shown. So again, inverse for the equation, we just swapped x and y. When you're graphing, you can still swap x and y. So this is going to be the point 0, negative 2, we agree, right? This is going to be the point 1, negative 6. And this is going to be the point negative 2, 6. So that's the function that they gave us, right? If I want the inverse, what I do is I flip the x and the y. So instead of the point negative 2, 6, I have the point 6, negative 2. Instead of the point 0, negative 2, I have negative 2, 0. And instead of the point 1, negative 6, I have negative 6, 1. And again, you only need 2 points to graph the line, so that should be enough. So we'll go to negative 6, 1, negative 2, 0, and 6, negative 2. And we'll graph that with my musical instrument. That line is the inverse. The function represented by this line is the inverse of the function represented by that line. Question 9 says, write the following equation in logarithmic form. If you need to type it in to get that little number, to get that base number like that 2, you use your underscore, okay? All right, I like thinking of these as just little circles, okay? So I have 8 to the power of 3 equals 512. First, I'm going to just start by writing the word log. Okay, and then my base of the log becomes the first number I see. So that 8 becomes the base of the log. All right. Now, I'm going to go in a circle. 8 in a circular pattern. The next number I see is 512. And then come up to the exponent. Good. So we see that this 8 is now the base. The base is the base. The answer is what we're taking the log of. And then the exponent is our answer. So my answer is log base 8 of 512 equals 3. Now they're asking us to go the other direction. So starting with log, write it in exponential form. So I have log base 2 of 32 equals 5. I'm going to start with my base. So we're just going backwards, right? So starting with 2, take the circle again. 2 to the power of 5 equals 32. Solve the following equation for x. So you're welcome to use your calculator. Here's how you would use a calculator. So instead of desmos.com/calculator, I would go to desmos.com/scientific. Darn it, I can't see my page anymore. And it was log. You can do log base 5 of 625, but your calculator usually prefers it to put log of 625 divided by the log of 5. And that'll give you the answer of 4. You're also welcome to turn it back into exponential form, right? So what would exponential form be? It would say, start with your base. So we have 5, go over here, to the power of x equals 625. And then you can either get a table out of powers or think 5 to the power of what is going to give me 625. 5 to the power of 5. Nope, that's too big. 5 to the power of 3. Nope, that's too small. 5 to the power of 4. That's what I was looking for. So x equals 4. Solve the following equation for x. All right. So we've got, you are definitely still welcome to put it into your calculator. The log of 1 over 27 divided by the log of 3. See what your calculator gives you, or you can switch it around, right? Starting with 3. 3 to the power of x equals 1 over 27, right? So we know it's going to be a negative number because it's a fraction. Let's see, 3 to the power of 1 is 3. 3 to the power of 2 is 9. 3 to the power of 3 is 27. So if I'm looking for 1 over 27, 3 to the power of negative 3 is going to be 1 over 27. So I can say that x is negative 3. I also put it in my calculator. Remember, I would not do log base 3 of 1 over 27. I would do log of 1/27. Oops. Divided. Oh no. I hit cancel. Start with parentheses. Log of 1/27 divided by log 3. Log base 10 of 1 over 27 divided by log base 10 of 3 is going to give me negative 3. And you can also check this answer. 3 to the power of negative 3 is 1/27. Solve the following equation for x. Log base 4 of x equals negative 2. So this one you can't just throw into the calculator, right? Because they put the x right here. But we can do the loop, right? Figure it out. Sorry, I didn't finish that loop up there. So we have log base 4 of x equals negative 2. Start with that 4. That 4 becomes your base. The negative 2 becomes your exponent. And then you got x. Now we just say, what is 4 to the power of negative 2? And then you want it in fraction form. 1/16. And that makes sense because 4 to the power of 2 is 16, so negative 2 is 1/16. And you can put it into your calculator as log, oops, did I learn nothing? Log of 1/16 divided by log base 10 of 4 equals negative 2. So that fit. Log base 3, oh, I was trying to scroll instead of moving my, I thought I could scroll on the camera instead of using my hand to move the page because it's just real life. All right, we have log base 3 of 1. Zero. Why? Because that is 3 to the power of x equals 1, right? That was x. I was just putting in x because we didn't know the answer yet. Or 3 to the power of 0 is 1 because anything to the power of 0 is 1. There's no other exponent you can make of 3 that would give you a 1. Now here we have log base 14 of 14. That's asking 14 to the power of what will give me 14, and that's just going to be 1. Welcome to put it into your calculator. Remember, it has to be log 14 divided by log of 14 to get 1, because if you just put in log 14, it's not going to work. Question 16 asks us to select the graph of y equals log base 5 of x, or, right, log base 5 of x equals y. We can still call that 5 to the power of y equals x if we wanted. That's kind of interesting, right? If I put it in x, I won't be able to solve it to find y, right? But if I put in y, I could solve it to find x. So you can use it in this form, or you can use it in this form. We're just more familiar with exponential form, just working with it throughout the semester. So I'm going to use this one. And I'm going to put in values for y instead of putting in values for x like I usually do. So when y is 0, right, then 5 to the power of y equals x becomes 5 to the power of 0 equals 1. So x is 1, y is 0. When x is 1, y is 0. When x is 1, y is 0, so it's not that one. When x is 1, y is 0, not quite. When x is 1, y is 0. It's either the first one or the fourth one. What other point would I see? Well, if I were to put in a 2, right? If I were to put in a 2, will that number be above? Sorry, child walked in. All right, so we are looking to input a y and find an x, right? So we're looking on y, right? When y is equal to -5 here, right? So this would be 0, -5. This one would be 0, +5, right? So let's put in 5 for y and see if we get a 0x. Y equals 5. So 5 to the power of 5 equals x. 5 to the power of 5. 3,125. So when y is 5, x is 3,125 when y is 5. So that's not quite what I had, right? I had that it would be either -5 or +5. Sorry, I had that when y is 5, x is equal to 0. See what happens when y is equal to -5. One over 1,000, 1 over 3,125. So that's kind of close to 0, right? Close to 0, right? a fraction very close to 0. All right, so when y is 5, x is going to be way over here, right? At positive 5, this is really close to 0. This is not, right? Not x equals 3, 1, 2, 5. It might be x is equal to 1 over 3,125, right? But it's not that x is way over here, right? For negative 5, when y is negative 5, x should be really close to 0. So for negative 5, this one is x is really close to 0, right? And for positive 5, x equals something really huge. Right? So this one's tracking. 1, 0. That's that point. 3,125, 5? 3,125, 5? No. Negative 5, 0? No. Right? So those are our points. Here, 1, 0, yes. 3,125, 5? Maybe, right? Negative 5, 0? Yes. So that's how I would do that one. That's because I converted it to exponents because it's easier. It probably wasn't easier in the end. Let's look at it as just the log. So we have log base 5 of x equals y. Make a new xy table. When x is, right? When x is 1, 2, that'll be enough information, right? When x is 1, we know y is 0. When x is 2, we want to find y. So that means it'll be log base 5 of 2 equals y. Put that into the calculator. Log 2 divided by log 5. 0.43. Would love for that to be a fraction. 0.43. So that means we've got the point 2, 0.43. It's not a negative 0.43, right? It's a positive. So 1, 0, 2, 0.43. That could be it. 1, 0, 2.43. No, because that went into the negative, so it's not possible. 1, 0. No. 1, 0. Maybe, but not really. 2.43? No. Good. So you're just plugging in x, finding y. We tried to do plug in y, find x. It got really confusing, I think. I apologize. All right. The properties of logarithms in this section can be used to rewrite log base 3 of the square root of 4 of x as follows. A log base 3 of b. Find the values for a and b. All right. Remember the rules for logs. I'm just going to show them, and we're going to decide which ones we can use, right? So we're looking at log base 3 of the square root of 4x. Well, we don't have anything being multiplied, right? We don't have anything being divided. We don't have, ooh, do we have something to the power? We do. Okay, so we're going to take that square root of 4 and we're going to change it. Do you remember how to change square roots into exponents? I'm going to rewrite log base 3 of the square root of 4x as log base 3 of x to the power of 1/4. Do you remember that rule? Okay, so now we have log base 3 of x to the 1/4. We can look at our rules for logarithms and see that if we have a power, rule 3, if you have a power, you can put that out in front of your logarithm. So we're going to do that. Okay, that 1/4 is now going to go in front of the whole log. And we're done. The confusing part was switching between that to that, and then you move that out in front. Then you're done. So A is 1/4, and B is your original x. Done. All right, use the properties of logarithms, which was that list we were just looking at, to rewrite the given expression as the logarithm of a single quantity, simplifying as much as possible. Good? Okay. Let's look at our list of rules. And we have 2 times log b of x minus 5 times log b of y. So we have the same log b base, so that's good. The base is the same. The first thing we're going to do is take those exponents, or sorry, take the number leading the log and turn it into exponents using the opposite of the rule we used for question 17. Okay? So for question 17, we had an exponent and we moved it out in front. Now I want to move those out in front back to the exponent position. Okay? So 2 log b of x becomes log b of x squared. Okay? This is up here. That minus sign is the same. That 5 log b of y is going to be log b of y to the 5th. Okay, it's not -5 because that minus is still there. So again, the number out in front became the exponent, okay? They want a single quantity simplified. So this is 2 quantities. They want a single quantity simplified. Good? All right, what is the rule about subtracting logs with the same base? Let's go look at the list again. Rule 2. Log base b of m divided by n is the same as log base b of m minus log base b of n. So we have it in expanded form, which is the form on the right, and we're going to put it into what would we say? We're going to make it into a fraction, I'll say, okay? So we're just going to take log base b of the first term, make that the numerator, and the log base b, that second term, we're going to make it the denominator, and we're just going to put log base b in front. Because it's subtracted, it's division. Log base b of, and we had, our first term was x squared, and our second term was y to the 5th. So that's how we determine which is the top. The top is the first term, the bottom is the second term. So we have log base b of, don't rewrite the whole thing, just put in x squared over y to the 5th. And you are done. They have the parentheses, no need to add the parentheses. Good? So we simplified it as much as possible. Question 19, expand the logarithm as much as possible. Rewrite as a sum, difference, or product of logs. Preserve order. Okay? So we just saw the rule, and that it's if it's division, it becomes subtraction, right? They have the same base because ln means it's the natural log. So it's the base e. 2 is on top, so it goes first. 15 is on the bottom. So the natural log of 2 divided by 15 is the same as the natural log of 2 minus the natural log of 15. I can show you. Show you it's true in case you wanted to know that. Gives you that, right? And then natural log of 2 minus natural log of 15 gives you that same number. Here they're asking us to expand the logarithm as much as possible, rewrite as a sum difference or product of logs, preserve order. All right, so do you remember when we broke? So this had terms in front that we made into exponents before we made it into a fraction, right? We did two different things. We moved these to the exponent, and then we changed the subtraction to division, right? Now they're giving us something like this, and they want to do it in reverse order. So I want you to do it in the same order we did it in. So backwards, the same, respecting the same way we went forwards, okay? You're reversing. So to reverse, we would go to minus before we would do the exponents. So that would be log base b of x squared minus log base b of y to the fifth, right? And then 2 log b of x minus 5 log b of y, right? So we're just going to do that for question 20. So first, well, you can't. Oh, sorry. First, change it from first change it from division to subtraction. First, change it from multiplication and division to subtraction. Multiplication and division to addition and subtraction. I need paper. So we've got log of a to the fifth, b to the eighth over c to the ninth equals, right? Plus, because that's multiplication becomes addition, minus, because now we're dividing. That was that. That's that one. That's that one, right? We agree? These are being multiplied, so it's addition. This is being divided, so it's subtraction. Good. Now we've got, I'm just going to rewrite it again. Log a to the fifth plus log b to the eighth minus log c to the ninth. Now what we want to do is take this, put it in front. Take this, put it in front. Oops, sorry. Take this, move it in front, messed up my color scheme. That means instead of log a to the power of 5, we have 5. Log a, keep that plus sign, 8. Log b, keep that minus sign, 9. Log c. And that's how I would enter it. That's expanded as much as possible. It's just giving you plus signs, so make sure you write a negative right here. So I will write that as 5 log A, 8 log B, negative 9 log C. Use the properties of logarithms to rewrite the given expression as the logarithm of a single quantity and enter the single quantity in the answer box to complete the expression. Right. So we just did an expansion. Now we're going to make it into a single quantity. The first thing you want to do is change from out in front. Turn that into an exponent. Okay, without the minus sign. Still. So that becomes log x to the power of 1/4 minus log y to the power of 3 minus log z to the power of 4. All right, now we are going, so we have used the rule for the exponents. Now we're going to use the rule for addition and subtraction, right? Which is that if it's being divided, we subtract, and if it's being multiplied, we add. These are clearly being subtracted, so we're going to change them to division. So we already have the log. What do we have on top? X to the power of 1/4. And I know it's really easy to overthink this because there's two minus signs. It just means put them both on the bottom. Y to the third, Z to the fourth. Don't overthink it. There's your answer. Okay, except fit it right there. Use the change of base formula to evaluate the expression as a quotient of natural or common logs. Use a calculator to approximate it to 4 decimal places. I mean, I'm just gonna put it in my calculator. Change of base formula means divide the top by the bottom. 27 divided by log of 2. 4.75, how many decimal places? 4.7549 would be 4 decimal places. Solve the equation for x and answer exactly. All right, for 23, they're asking us to solve the equation for x, and the equation is log base 2 of 5x minus 5 equals 3. What I would do is I would change this from logarithmic form into exponential form. So what we're going to do is we're going to start with that 2. 2 to the power of 3 equals 5x minus 5. Now we can just solve an exponential equation where we know both the base and the exponent. 2 to the power of 3 is just 8. So now it's 8 equals 5x minus 5. We're just going to solve for x, add 5 to both sides. 13 equals 5x. Divide both sides by 5. And we get x is 13/5. Here we have log base 12 of x plus log base 12 of x minus 4 equals 1. What we can first do is combine these two terms. So we know when we have an addition, we can, we have an addition sign, we have logs of the same base. That means we can multiply x times x minus 4. So I will have log base 12 of x times x minus 4 quantity equals 1. Now we're solving for x. I don't think it matters whether you distribute the x first or you change it from logarithm to exponential form. So I'll just go straight to putting in exponential form. Remember, we start with that base. So we go 12, go in a circle. 12 to the power of 1 equals x times x minus 4. 12 to the power of 1 is just 12 equals x times x minus 4. Now I'm going to distribute that x. 12 equals x squared minus 4x. You still want to find x, and you have an x squared and an x. So I'm going to put it into ax squared plus bx plus c form and try to see if I can factor it. So to do that, I'm going to set it equal to 0. So I'll subtract 12 from both sides. And I get 0 equals x squared minus 4x minus 12. Now, a is equal to 1, b is equal to negative 4, and c is equal to negative 12. So if I was going to factor it, I would need two numbers that multiply to equal negative 12, but add to equal negative 4. You have 1, negative 12, 2, negative 6. And 2 and negative 6 work, right? Because if I add those, I get negative 4. And if I multiply them, I get negative 12. So I'm going to say 0 equals x plus 2 times the quantity x minus 6. Set each of those equal to 0. 0 equals x plus 2 means that x equals negative 2. 0 equals x minus 6 means that x equals 6. We cannot have negative logs in our answer. Here, this is log base 4 of x. So if x was negative 2, it wouldn't count. So we're just going to say that x equals 6. We're going to ignore the negative answer we got for 25. Okay? This says use the one-to-one property of logarithms to solve and answer exactly. All right, I just realized something. Up here I said, oh, I just totally skipped 25. So 6 is the answer to 24. You were following along, you probably caught that faster than I did. All right, so 25, I'll just write right here. So we're solving for x log base 4 of x plus log base 4 of x plus 6 is 2. Again, what we can do is combine them. So this is going to become log base 4 of x times x plus 6 equals 2. We're going to turn it into exponential form. So we start at that 4. Comes 4 to the power of 2 equals x times the quantity x plus 6. Simplify that. 4 squared is 16. X times x becomes x squared. X times 6 is 6x. Set it equal to 0. 0 equals x squared plus 6x minus 16, because I subtracted 16 from both sides. Now we're trying to think of any factor pair that multiplies to equal negative 16 but adds to equal 6. We've got negative 1 and 16, negative 2 and 8. Well, that one works, right? 8 minus 2 is positive 6. So 0 equals x minus 2 times the quantity x plus 8. That means x equals positive 2 and negative 8, but remember we ignore the negative, so we just say x equals 2 for 25. Sorry for missing that. Question 26 asks us to use the one-to-one property of logarithms to solve. Now, the one-to-one property means that if you have logs of the same base on both sides of the equal sign, you can just drop the logs. So that means we can just say 3x minus 5 is equal to 7 minus 3x. We just drop the log. Now you're just solving for x, so you're going to move your x's to one side. I like to move left. 6x minus 5 equals 7. Now you're going to add 5 to both sides. 6x equals 12. Divide both sides by 6, and you get x is 2 for 26. Good. All right. Same exact property. One-to-one property means the logs to the same base are equal to each other, so you can just forget the logs. ln is the natural log or log base e, so you can just get rid of them, and now we have 6 minus 5x equals negative 6x. I'm going to move my x's to the left, so I'm going to add 6x to both sides. That leaves me with x, but you still have that 6 equals, there's nothing over here, so I'm going to put 0. Subtract 6 from both sides, and I get x equals negative 6. Question 28 asks us to find x in the following equations. And they've given us, for part A, they gave us the natural log of x is equal to 3. What I'm going to do is I'm going to switch that into exponential form. Now you're thinking, I don't have a number right here, but remember, ln is the same as log base e, and e is a number or a value like pi, right? So when you turn on your calculator, you will have a button for e. See that one? E is 2.71. Good. There you go. Better. Okay, so that means that when you see natural log of x equals 3, you can also call that log base e of x equals 3, and we can still do our little circle. So starting with e, go over to 3 becomes your exponent, and x becomes the answer. Then you're just putting that in your calculator. E to the power of positive 3 is 20.0855, but they ask you to round to 2 decimal places, so you're just going to write 20.09. Same exact thing. We have log base e of x is equal to this time negative 5, so we're going to start with that e. Go over to the negative 5, so e to the power of negative 5 equals x. What is e to the power of negative 5? Don't use minus. 0.0067. If you had to round that to 2 decimal places, 0.0067 to 2 decimal places means right here. 0, you're not just going to put 0.00 because that 6 is higher than a 5, so you're going to put 0.01. That was kind of tricky. That would be my answer. It's approximately. Good. Here they're asking us to simplify the natural log of e to the power of 16. You can definitely put it into your calculator. What your calculator is going to tell you is the natural log of e to the power of 16 is just 16 because what we're doing is log e, e16 equals x, right? If I was to do the loop, start at your base, e to the power of x is equal to the exponent, which is e to the power of 16. What is x? X is going to be 16, and that's what our calculator said as well. Log the power log base 10 of the 5th root of 10,000. Interesting. All right, so I'm going to change this. I mean, you don't really have to change it, but It's kind of easier to put it into your calculator. Log base 10 of the fifth root of 10,000 is just 10,000 power of 1/5. Or, where is it? No, I didn't want it to be a 10 response. I wanted it to be 5. So 5, fifth root of 10,000 is that. Which is also so those are the same value, right? It's just a different way to write it. Okay. Now, does it help us at all to change it to exponent form? So starting with 10, 10 to the power of x is equal to 10,000. Simplify the following expression. Yeah, I think they want us to just simplify so that you have the same base. So how do you get 10,000 to base 10? If these both have, so now that we have 10 to the power of x is equal to 10,000 to the power of 1/5, we want to get the same base so that we can get rid of the base and just use the exponents, okay? So 10 to the power of 1 we know is 10. 10 to the, divided by, no, to the power of 2 is 100. 10 to the power of 3, 1,000. 10 to the power of 4, what do you think it's going to be? It's going to be 10,000. So 10,000 we're going to rewrite as 10 to the power of 4. 10 to the power of x is equal to 10 to the power of 4 to the power of 1/5. So we're not just multiplying them, right? We're taking a power to a power, so that means we multiply them. We're not just adding them. Because if it was 10 to the power of 4 times 1/5, then that would be 10 to the power of 4 plus 1/5, right? But we're not multiplying them and they weren't side by side. This one was inside this one, so we're taking 4 to the power of 10 to the fourth to the power of 1/5. So that means we're going to multiply them. So then 10x is equal to 10 to the power of 4 times 1/5. What is 4 times 1/5? It looks like it might be confusing, but all you do, right? 4 is being multiplied by 1, which is divided by 5. 4 times 1 is 4. So it's just 10x is equal to 10 to the power of 4/5. Now you can get rid of the base. X equals 4/5. Log of, see if I can just put it in my calculator. Welcome to just put it in your calculator. But that's why it's true, if you were to do it mathematically. All right, use like bases to solve the exponential equation. We just used like bases right here. We took 10 to the power of x and 10,000 to the power of 1/5, and we made it sure they had like bases so that we could cancel the 10s and say that if the bases are the same, we can just set the exponents equal to each other, right? Okay. So for 31, the bases are the same. We have 5 to the power of negative 3a plus 2 equals 5 to the power of negative 3a. So those bases are the same. So we get rid of them and we just say negative 3a plus 2 is equal to negative a. I almost called it a 9 because I don't know how to write. Now you just solve for a. I'm going to move that a over. Kind of makes sense to move the 3a over, but whatever. Negative 2a is equal, oops, sorry, plus 2 is equal to 0. I'm going to subtract 2 from both sides. Negative 2a equals negative 2. Divide by negative 2. Divide by negative 2. A is equal to 1. 32. Ooh, we're almost there. Solve the exponential equation and use a calculator to write the answer in decimal form to 4 decimal places. All right, remember, I start with writing log. Oh, sorry. So I'm going to change this to logarithmic form. I write the log, and then right next to the log, I write the base. So base is 9. I'm going to put a 9 right here. Okay. Then I'm going to circle over to the 4. So log base 9 of 4 is equal to 2x plus 1. Good. All right. Now we can take log base 9 of 4. And remember, the way that we do that is we take log of 4 and divide it by, I'm going to need that parentheses, log of 9. Get 0.63092. Make sure it's not a fraction. It's not. Point 630975536 is equal to 2x plus 1. So I'm just going to subtract 1 from that. Now we've got, and I'm going to jump down here. My calculator says negative 0.36907024464 equals 2x. Divide both sides by 2. And I get negative 0.18453512232 is equal to x. How did they ask us to write it? To 4 decimal places? 1, 2, 3, 4. That's a 3, so it's less than 5. So my answer is just x equals negative 0.1845. Good. All right. Suppose the population in a small city is 61,000 in the beginning of 2012, and the city council assumes that the population has been growing at the same rate and can be estimated by the equation. When did the city have a population of 34,000? Okay. So this is the equation. P equals 61,000 e to the power of 0.04 times t. P, population. T, time, right? I mean, they don't say it, but I'm going to assume. Our equation is P equals 61,000 times e to the power of 0.04 t. What did they give us? They gave us the number 34,000. Is that time or is that people? That is people or population. 34,000 equals 61,000 e to the power of 0.04 t. Now I just have to solve for t, which, and then maybe compare that number to 2012. But anyway, let's start by isolating e, right? E right now is being raised to the power of 0.04 t, and that's what we want to solve. So first we're going to get e alone. It's being multiplied by 61,000, so we'll divide both sides by 61,000. 34 divided by 61. Missing a zero there. 34 61s. E to the power of 0.04 t. All right, what do I do now? Now I'm just going to flip it over to E on the left, and then my constant on the right. Good. I'm going to change this from exponential form to logarithmic form. What do I do first? I write the word log, and then I start with my base. Log base E of, and I jump over here, 34 over 61 is equal to, and I take that exponent, 0.04 times time. Now we can solve it. Remember, log base E is just the natural log, so you don't even need to do any compound logs. The natural log of 34 over t. Oh, sorry, 34 over 61. I didn't write what the 1. And just to be sure, you can also do log of, good gracious, log of 34 over 61 divided by log E. I'll give you the same answer. Now, still trying to solve for t. So t is being multiplied by 0.04. So we're going to take that number and we're going to divide it by 0.04. And we get negative 14.61 to 83349 equals t. Negative 14.612833349. The city had a population of 34,000 people in the year negative 14. That doesn't quite make sense, right? Instead, we're going to take the first year they started. They started in 2012, and we're going to subtract that number. What do you get? I subtracted a negative number. Ugh. 14.612833349. 1997. That's going to be my answer, 1997. All right, guys, that is it for exam 4. I hope this helped. Please email me if you have any questions.